Okay, so in the next example, we have example 9a. Find the tangent vector for a given metric of vector function. So second, let me adjust first. Okay, vector r is given by 2 sin t. Sorry, should be this one, negative cos 2t and then sine 2t. Okay, sketch the curve, the position vector and tangent vector. Okay, so meaning that here there are two just to get the unit tangent vector. Right, so just tangent vector, just r prime at specific t. Okay, so firstly, tangent vector. So we obtain that we got 2 sine 2t and then 2 cos 2t. Okay, 2 cos 2t. Then because they give you the specific value of t, so the tangent vector at t equal to pi over 2, pi over 4, right? Pi over 4, pi over 4. So 2 sine pi over 2, because we have square there, 2 cos pi over 2. Okay. So I don't have the calculated now. So the graph of sine, so 0. Okay. No, sorry. It should be here. Pi over 2, so 1. Just 2. Okay. And then the graph of cos, pi over 2 here. So 0. So that is our tangent vector. And also because you need to sketch later on, so you have to also have the position vector at r at t equal to pi over 4. So negative cos pi over 2 and then sine pi over 2. So we obtain that. We have 0. So cos pi over 2 0, sine pi over 2 is 1. So we got 1. So that is our position vector. Okay, what else that we need? Sketch the curve after that. So we have the position vector, yeah, this one. And then we have a tangent vector, yeah, we got that. So now it's time for us to sketch the graph. Okay, so how can we sketch the graph? From the previous examples, we have, I think I showed you how can we sketch the graph if the parametric equation or the vector function is in trigonometric function, which means that you cannot just do the direct substitution as you done on the previous example, but you have to use the identity of trigo. Okay, which means that in this case you have the parametric equation x equal to negative cos 2t and y equal to sine 2t. So you have the same 2t here. It looks like we can use direct, just use identity of trigo, which we have the something like cos square a plus sine square a is equal to 1. So we need to square both sides. So x squared will give you cos square of 2t. And this one, square both sides. So you will have sine square of 2t. Okay, so now how can we eliminate the t? then you have to apply the trigonometric identity. So you have x squared plus y squared will give you cos square 2t plus sine square of 2t. And we know that from the identity of trigo, this is equal to 1. So then we can convert from the equation in terms of t into the Cartesian form. So we have a circle with radius 1 and center at the origin. Okay, so now where is the center? Where is the in which dimension the circle that we have to sketch here? 2D or 3D? Now you look at here, they give you in the component form, so we know that this one's supposed to be x and this one's supposed to be y. So you have only two axes, x and y, meaning that you have to sketch that circle on y-x plane. So you have y and you have x and you have a circle with radius 1 center at the origin. So that is only the sketching of the curve. And the question here, actually I'm asking you to sketch the position vector and the tangent vector as well. Okay, so normally in exam they will give you the complete instruction. Okay, this is for the sake of example in class, so that's why it looks like the instruction is just incomplete. But in exam we make sure that everything's clear. Okay, if you want you to sketch or label the position vector, and we will say it. Okay, so here firstly you have done sketching, yes, and then show where is the position vector or label the position vector. So where is your position vector? 0 1. Okay, 0 1. So where is 0 1? 0 1 x 0 1 1. So over here. So label the position vector. So you have to label. So it should be a straight line from the, you have to provide an arrow, a straight line starting from the origin. So that is your position vector, and you have to label that. So this is the position vector of r when t is equal to pi over 4. So that is the sketching of the position vector. And then where is the tangent vector? So your tangent vector just now r prime at t pi over 4, you got 2 0. Okay, so now your r prime at pi over 4 give you, from your calculation, you got just now 2 0. And remember the process sketching of the tangent vector, velocity vector, unit tangent vector, unit normal vector. What else? They must be start at the position, your position. So in this case, your position is at this point, 2 0. So you should be consider this just like your origin. Okay, so for the sake of plotting, so for plotting, so your r prime at t pi over 4 should be considered your position just now. So your position, so I should write here, your position vector is just now 2 0. So you have to add the component. Is it the same? No. So this, so 1 0 1, sorry. So 0 1. So for plotting, you have to add your x component with your position and your y component with your position. So now for the sake of plotting, so your new location of r prime or your tangent vector is located at 1 2 1. Okay, now we find out where is the 2 1, the point of 2 1. So the point of 2 1, so this one 2, this is 1. So here. Okay, so now how can you put the label or sketch it? So please don't put the line, the arrow starting from the origin. If you do like that, So this is wrong. So this is only for position vector. Okay, so that is wrong, which means that you have to start at your position. Start at your position. So where are you now? So you are here, right? At 0, 1. Okay, at 0, 1. So you have to provide the line, because you put the, for the sake of plotting, you considered this one 0, 1 into your R prime. So in order for you to sketch the graph, you should start from the 0, 1 as well, from your position. So you have this particular graph. Okay, so meaning that now the idea, this is R prime T vector. Sorry, not T, but T pi over 4. Pi over 4. Just like the unit tangent vector, but unit tangent vector, the same direction, but the vector is a bit smaller, like that, because we know that the magnitude is always equal to 1. But this one is a tangent vector, and it should be longer. And then from the, how can we know this is correct? So we know, as I mentioned before, as I explained to you before, the property of the tangent vector or unit tangent vector. So it's I mean at the turning point, so the direction of this, this is direction, will show you that you are moving in this way, which is clockwise direction. Clockwise direction. So how can you know that? How can you know that? From this direction. So this direction from the provided by the unit tangent or tangent vector tells you that what is your direction of your when you are moving. Okay, so imagine this is your curve, and it is closed curve. You are moving around along this circle. So now this, from this unit tangent or tangent vector, we know the direction without putting all the values. Okay, last time I explained to you without before we learn about the tangent vector or unit tangent vector, so you have to plot all the point and you can see the movement of the particle. But now actually without that particular step, so you can also know the direction by finding the tangent vector or unit tangent vector. So you know that the direction is over here, so you know that the graph, you are moving around the circle in a clockwise direction, because you see this direction tells you that you are moving this way. But if you, let's say, compute and then plot, and you will get that, let's say you got that, so now you know that you are moving that way, so you are anti-clockwise direction. So understand? Hopefully you clear with that. So have we answered all the question? Position done, tangent done. So that's it. Okay. Let's say you have the same vector function, but I add, okay, let's say here there is a z component. So let's say this is another story. Okay, so let's say here you have the component z, which is 5. Okay, so how can you sketch the vector function and also all those things? The let's say they have a same question, but you just add one more term which is belong to z, which is 5. So your calculation all the same, but okay, because we have x, y, and z, so your curve is located on 3D system. So let's say this is your x, and this is your y, and your z. So we know that for x and y, you still have a circle. You have a circle, you have a curve in space. But then when z is equal to 5, so actually you are moving around. The circle is, you're just circling around z equal to 5. Z equal to 5. And then, about the position vector, so now you have to add one more term, which is 5. So your position vector is now at 0, 1, 5. So you have at, so this one 1, so this one 1. Okay, so that is because we know that circle is radius 1. And then where is your this is your point on 2D. So where is the point here on this 3D? So y1 so supposed to be over here because z is always equal to 5. So then how can you label the position at t equal to pi over 4? So you just start from, this is position, yeah. So start from, I don't want to use the same color. So just draw a, put an arrow. Now this is in 3D, yeah. So r pi over 4. So this is the position of the vector function when t is equal to pi over 4. Okay, so where is your r prime? So r prime we have calculated here. So your r prime is 2, 1. So this is the original one. So when you calculate that, so it should be from here. Okay, so your r prime is, now it's become differentiate, so it is 0. Okay, so that is 0, and then when you substitute 0, so here you have 0. So that is your tangent vector 2, 0, 0, 2, 0, 0. So for the sake of sketching, plotting, so you just add 0 plus 2, you got 2, 1 plus 0, you got 1, and then 5 plus 0, you got 5. So this one now becomes 5. So where is 2, 1, 5? 2, 1, x 2. So let's say this is x. So that one, and then 5. So maybe here. Remember this is 3D, yeah? So this is on the plane z equal to 5. And then how about your graph of r prime for this new function? So now your graph, you should start from point here and you point to that direction. Okay, so this one is your tangent vector when t is pi over 4. Where imagine now when you are standing over here, so you're looking down, so you can see just xy plane, right, where your vision is actually here when you are watching or looking downward from z. So you can see the same thing here. But now we are talking about the new example where the z is equal to 5. So then your correct sketching of the curve, it should be here. Okay. So don't be confused. Actually, the real example, the example given here just 2D. So it just enough. Just stop here. So that is your answer. But now I expand. Let's say they give you another component of Z5. So what happened to your graph? So this is your graph. Your graph looks like. So hopefully you clear with that.